Mass of the Earth. So we will consider a body of mass m is located on the surface of the Earth. This is a body of mass m. This is located on the surface of the Earth. So capital ME, this is the mass of the Earth. ME, this is the mass of the Earth. Small m, this is the mass of the body. R, this is the radius of the Earth. So this body of mass m is located on the surface of the Earth. So we have represented the mass of the body with a small m, mass of the Earth with me, and radius of the Earth with the r. So the force of gravitation which is acting on a body is taken out by the formula F is equals to capital G, small m, mass of the body, mass of the Earth, and square of the radius. We know that force is equals to weight and weight is equals to mg. So in place of force, we will write here mg. mg is equals to remaining same formula we will write g m capital M E over r square. After that, same values will cancel out and the remaining formula will be G is equals to capital G M E over r square. And here we have to find out the value of mass of the Earth. So we will rearrange the formula to find out mass of the Earth. Mass of the Earth is equals to r square G over capital G. ME, this is the mass of the Earth, r square, radius of the Earth, G, gravitational acceleration, capital G, gravitational constant. After that, we will put the values inside the formula. The value of radius of the Earth is equals to 6.4 multiplied 10 raised to power 6 meters square, and the value of gravitational acceleration 10 ms minus 2. And the value of gravitational constant is 6.673 multiplied 10 raised to power minus 11 Newton meter square per kilogram square. In this way, we will find out the value of mass of the Earth, which becomes equals to 6.0 multiplied 10 raised to power 24 kilogram. Variation of G with altitude. The value of G we will find out with the help of formula GH is equals to capital G ME over R square. The value of G is inversely proportional to the square of the radius, and this value of G change with the altitude. Altitude is the height of an object or place at sea level, and the value of G becomes greater at the sea level as compared to the hills. So we will explain a body of mass m is located at altitude or height h. This is a body of mass m. This mass m is located at a height or altitude. This altitude or height we have represented with the symbol h. The distance of the body from the center of Earth becomes r plus h. So this is the body of mass m which is located at height. So the distance of this body from the center of the Earth, it will becomes r plus h. So the value of G at altitude we can find out with the help of formula GH is equals to capital G ME R plus H. The value of G we will find out at height. This is the value of gravitational constant, mass of the Earth, radius of the Earth plus height. So if the height is equals to 1 radius of the Earth, so the value of G becomes 1/4 to its value on the Earth. And if the height is equals to 2 radius of the Earth, so the value of G becomes 1/9 to its value on Earth.